Okay, this time we're sketching some trig functions. They're all fairly standard and you should be able to put them in Wolfram Alpha or something like that to see what they look like. But let's see if we can do it by hand. If we're looking at the unit circle definition of sine, we're considering a point P as it moves around the circle in an anti-clockwise direction starting from positive x direction, and the sine of this angle that we've gone through, the sine of theta, is simply the y coordinate of this point. So let's see how we go. Let's draw up a table, which is always the first thing to do here, and after a while you get used to the idea that the critical points for these functions are usually 0, 45, 90, basically the quadrants. So let's just look at 0 degrees, 90 degrees, 180, 270 and 360. So I'm looking at each of the main directions. And there's 0 degrees or 360. So when the point P is here, its y coordinate is 0. So these are my x values for my angles. The sine of 0 is 0. At the time P has moved up to here, remembering that this is the unit circle, which I forgot to stress earlier on. So the radius is 1. By the time it's up here, its y coordinate is 1. At 180, its y coordinate is 0. At 270, it's gone down to -1. And at 360, we're back at 0 again, which is what we'd expect. So now, the function is going to range from 1 to -1. This is my y-axis, this is my x-axis. And let's split it into half for starters. 180 degrees, 360. Split them in half again, 90 degrees and 270 degrees. And mark up our points. 0 there, 1 at 90, 0 at 180, -1 at 270, and back to 0 at 360. Now the only thing to get the shape really nice is that initially, as point P starts to move around the circle, its y coordinate is changing fairly quickly because it's moving almost parallel to the y-axis. By the time it gets to 90, its y coordinate is changing very slowly because it's moving almost parallel to the x-axis. So that means the slope of the sine function is very flat at these points and reaches its steepest at 0 and 180. So that is pretty much what y equals sine x looks like. Okay, now onto a slightly trickier one, y equals tan x. Now we know that y equals tan x is the same as y equals sine x over cos x, because that's the definition of the tan function. Now we are going to have a problem if cos x equals 0. Going back to my unit circle diagram, and the definition of the cosine of x is the cosine of x is the x coordinate of the point P as it moves around the circle. Now the x coordinate is going to be 0 at 90 degrees and 270. So they're the points where we're going to have a problem. Let's make a table again for the same points: 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now, this is probably not going to help much, but let's fill it out anyway. From above, we know the sign of x at each of these: 0, 1, negative 1, 0, negative 1, and 0. And the cosine of x at each of these is 1, 0. So the x coordinate of the point P at 90 degrees is 0. At 180 we've got negative 1. At 270 we're back to 0 again, and at 360 we're back at 1. So now let's look at tan x, which is simply sine x divided by cos x. So 0 divided by 1 is 0. 1 divided by 0, strictly undefined, we'll call it infinity. 0 divided by negative 1 is negative 0 if you like. Makes no difference, it's still 0. Negative 1 divided by 0 we're going to call negative infinity. 0 divided by 1, back to 0 again. Now, let's draw these points. We're not really going to... okay. Something I should have seen before. And very important to stress, always read the question carefully. I was going to go from 0 to 360. We actually want to go from negative 90, which I haven't got in my table yet, but let's put it in here. 0, so try and keep the intervals about the same. And this will be 90, 180, 270, 360, and let's get my y-axis in there. Now we can plot the points we've got and then see where to go from there. So tan of 0 is 0. Tan of 90 is undefined. It means we're going to have a vertical asymptote there, and the same at 270. And using the same logic, you'll find, notice these are 180 degrees apart, 180 degrees back here. We're going to end up with another vertical asymptote. Now I know at 90, if we were continuing on this way, we'd be up somewhere really, really high. At 180, I'm back at 0 again. And at 360, I'm back at 0 again. Now, like I said, really what we've got so far is not very helpful in drawing a tan graph. So let's try and fill in some gaps. Let's see what happens if I put 45 degrees in here. Now you could use your calculator to work out the tan of these, but at 45 degrees in a right angled triangle, these sides have to be equal. So if this is the sine of 45, this is the cosine of 45, they're equal to each other. We don't really need to know what they are, but we know that the ratio sine over cosine will be 1. Now let's think about theta being in the second quadrant. The sine is going to be positive, the cosine is going to be negative. They're the same size, but one of them is negative, so negative 1 is going to be the tan of 135 degrees. And back in the third quadrant, again the sine and the cosine are going to be equal in size. They're both negative, so when we divide one by the other, the answer is going to be 1. And the angle 45 onto there is 225 degrees. If I wanted to check, I could add 45 onto there and see I get to 270, which I do. Okay, this should be enough now. I haven't defined my vertical scale. Let's make that 1, which means -1 is down about here. So halfway between 0 and 90, we're up to there. And we know as we get to 90, we get to infinity. So we're going to be doing something like this. Between 90 and 180, we're at -1, exactly halfway between. Halfway between 180 and 270, we're up to +1. So the tan graph comes back from -infinity after having disappeared to +infinity and repeats the same pattern. This is a feature of all the trig functions. They've got the same pattern repeated over and over again. We could work through this if we wanted to, but I think we can see that we're going to have a -1 there at -45, and the little bit that we're missing, again halfway between here, I'd be expecting a -1 again, and we'll start to see the -infinity up to 0 pattern happening again. And that is that one done. Function is y equals tan x. Much harder than sine and cosine, but there you go. Haven't got much choice. Now back to an easy one. The only thing that's slightly different here is we're multiplying the trig function by a number and we're subtracting something from it. So let's make up a table again and pick some values for x. Same values. And first work out the cosine of x. Cosine of x is the horizontal coordinate in the unit circle. So it's 1 when the angle is 0, it is 0 when the angle is 90, it's -1 when the angle is 180, 0 at 270, and back to 1 at 360. It's going to look similar to the sine function, but out of phase. Anyway, we'll see that as we plot the points. So let's do this in simple steps. If we multiply the cosine of x by 2, some people put brackets around x just to make it clear what you're taking the cosine of. What I wrote in the previous line is pretty standard notation as well. In this case, it's good to have a bracket around the x, so it's very clear that you're not taking the cosine of x minus 1. Anyway, 2 times the cosine of x, 2, 0, -2, 0, 2, and now 2 times the cosine of x, minus 1, 2 minus 1 is 1, 0 minus 1 is -1, -2 minus 1 is -3, -1, and 1. Okay, now all we have to do is plot them. X-axis, y-axis, make that 360, 180, coordinates. Okay, let's plot at 0. I haven't labelled my scales yet. 1, -1, -2, and I didn't make this one long enough. -3. We start out at 0 degrees, we've got 1. At 90 degrees we've got -1. At 180 we've got -3. At 270 we're back to -1 again. At 360 we're back up at 1. The similar reasoning that I used for the sine graph, the cosine is changing fairly slowly when x is 0. Actually, at x, we won't go into that, that's calculus, but the slope is close to 0. It's steepest when it's at 90 degrees and it's moving pretty parallel to the x-axis for a very short time. And it's going to be pretty flat again here, so sketching in between. Oops, not going so well there. We're going to get a function that looks something like that. Good enough for freehand anyway. Okay, fairly long question, but that's it. And this is always a way to go about it. Set up a table, get a few points, plot them. If you can't work out where it's going to go, then fill in a few more like we did with the tan graph. But basically get used to the idea that they're all sine and cosine are wave functions. Tan is going to be trickier because you've got these vertical asymptotes, but once you work out where they are and you know that the pattern is going to repeat, not too bad. Anyway, hope that helped. See you next time.